Hello, and welcome to this session on the MEDIATOR Design Pattern. This video is part of a 20 hours Udemy course where we cover hundreds of real-world design pattern scenarios. The MEDIATOR Design Pattern is a behavioral design pattern that promotes loose coupling between a set of objects by centralizing their communication through a mediator object. It allows objects to interact with each other indirectly through the mediator, rather than directly communicating with each other. This helps to reduce the dependencies between objects, simplifies their interactions, and enhances their reusability. In the mediator pattern, the mediator object encapsulates the communication logic and controls the flow of messages between objects. It acts as a centralized hub or facilitator that coordinates the interaction between the participating objects. Instead of objects communicating with each other directly, they send messages to the mediator, which then handles the routing and delivery of those messages to the appropriate objects. By decoupling objects and relying on a mediator, the mediator pattern enables objects to focus on their individual responsibilities without being aware of the details or existence of other objects. This promotes better encapsulation and modular design. Hello and welcome back. Let's take another real-world code example of an air traffic control system using the mediator design pattern. And in this example, we'll have an air traffic control mediator class that acts as the central mediator for the air traffic control system. It maintains a list of registered aircraft, and it also provides a method for registering the aircraft. It also has notify aircraft method that loops through all registered aircraft and allows only aircraft that are not the sender to receive the message. Now let's implement the aircraft, which are the participants in the aircraft traffic control mediator. The aircraft class represents individual aircraft in the system. Each aircraft has a call sign and a reference to the mediator. It also implements two methods, the send message method and the receive message method. The send message method is used to send messages to other aircraft through the mediator, while the receive message is called by the mediator to deliver messages to the aircraft. So the send message method simply sends a message through the mediator, and that calls the notify aircraft method of the mediator class. And also the receive message only prints out the notification that is sent to other aircraft. So an aircraft will send a message, and other aircraft that are in the mediators will receive the message using the receive message method. Let's run the code again. We'll create the air traffic control mediator. We will create first aircraft. The first aircraft will have its call sign and then the mediator that it's using. And let's create two more aircraft. We have aircraft 2 and aircraft 3. Now let's register the aircraft so that the aircraft are registered in the aircraft list as aircraft that messages need to be sent to. Let's register the other 2 aircraft. So we have 3 aircraft registered here. Now let's attempt to send a message from aircraft 1, and the message says send message traffic adversary descending to 10,000 feet. And this message will be received by the other 2 aircrafts. Let's run the code in our output tab, and you can see here when we send the message through traffic 1 is flight 123, it sends that message to aircraft 456 and 789. Those are the other aircrafts that are in the list. I can also send another message. Let's say we send through aircraft 2, and now the message through aircraft 2 also goes. Okay, let me separate them. Let me put a print method here. Okay, you can see the first message that I sent went to aircraft 456 and 789. And then for the second message, it went to flight 123 and 789. This video is part of a 20 hours Udemy course where we cover hundreds of real-world design pattern scenarios. The course is called Design Pattern in Python with real-world code examples. We showed via practical coding how design pattern is implemented in real-world scenarios like event manager, cache, database connection codes, document management code, creating optimized configuration settings, login frameworks, GUI framework codes, plugin systems, game development codes, payment gateway, document generators, computer graphics generation codes, financial model code pattern, resource pooling, object pooling in ORMs, website creation, database query codes, language translator, web application framework creation, banking system codes, organizational chart creation, file system, interpreter, menu system, text formatting code, authentication code, authorization code, API for OS, document management system, create proxies, event handling, middleware in web development, workflow system, undo redo functionality in apps, job scheduler scenarios, parsers, chart applications, drawing applications, notification system, distributed system, booking system, workflow management system, sorting algorithm, file compression utility, and many more. If you are really serious about your career in programming, you have to get this video. And you don't have to be a Python programmer to use it. Use the link in the description to get the best price for this course on the Udemy platform.